y squared equals 4 times bracket 3 minus x. Let's compare that then with our archetype or parabola, which we label as what? Capital Y squared equals 4ax. So here the y-axis remains unchanged. Capital Y is the same as y. A is equal to 1 and the capital X corresponds to the 3 minus x value. So what does that tell us then? Well, when x, this is a lowercase x, so let's just emphasize that by just putting a little x there. So when x is 3, the capital X is 0. So let's mark off the axes at the value 3. This is our capital X axis, as it were, and that value is 3. What's interesting here is that when x is bigger than 3, this value is negative, so this product is negative, isn't it? And you can't get any values. So the parabola is not going to be this way around because there aren't any values that side. So that confirms what we expected, was it's going to flip around because we've got this 3 minus x. So just to get a couple of values, if you put 0 in, you'll get y squared equals 12. So can you see in your mind's eye that it's just going to come around this way and be the opposite direction? So if that's the case, then the vertex will be A is 1. So it would be 1, here's the x-axis, but it would be 1 when it's coming, instead of going forwards 1 to A, it will go back 1. So this point would be 2 and 0. And this would be the focus. So let's just label that. And then the directrix, if we think about it, we've gone that way 1 from 3. If we come this way 1 to the value 4, this should be the directrix, shouldn't it? So let's just label that as well. So this is the directrix. And now we're fairly okay to draw it through the vertex. Here's our vertex, of course. So let's have a go at drawing it. So it's going to come up and around like so, like a parabola, but just the opposite way around because this is flipped and it comes out at the vertex at the point 3. So now we want to check it. So let's just do a quick check to see if we've got everything labeled correctly. The focal length here is from here to here, which is a distance 1. So I'll just put that in there. That's focal length is 1. So here's our point P. So we said that if we drop a perpendicular to the directrix, which is like so, and then we take a line from the point P in general to the focus, then those distances will be the same. So let's just check from our picture then that we get the parabola in question. So we'll write the word check because that's what we're doing. If we get time at the end of a test or an exam, we could do, this is one of the sort of checks we could do. So this squared, well, it's x minus 2 is the x value, isn't it? So it's x minus 2 squared plus y squared is the distance squared, is equal to the horizontal distance will be x, take away the directrix value for x minus 4 squared. So let's see what we get. We get x squared minus 4x plus 4 when we expand that bracket, plus our y squared is equal to x, expand this bracket now, x squared minus 8x plus 16. Leave the y squared where it is. The x squareds cancel, of course. The minus 4x can come over, to plus 4, so minus 8 plus 4 is minus 4x. Then we've got a 4 to take over, 16 take 4, so those two are done. And then we've got 16 take 4. When we move the 4 over, it is plus 12. So that's equal to then 4, 3 minus x, isn't it? That's the 12 there. And I've written this first term second, that's the minus 4x. So that's okay. Y squared equals 4 brackets 3 minus x. Let's have a look back. And yeah, that's what we got. So we've confirmed that we're on track here with these, finding out these things.